Welcome back to The Explainer. Today, we're unpacking a fundamental breakthrough in how artificial intelligence handles information. If you've been anywhere near the AI space recently, you know that keeping these models actually grounded in facts is, well, it's easily one of the hardest challenges in the entire industry right now. But straight out of the NeurIPS 2025 MMU-RAGent competition, there's a fascinating new system called NightFeats. It's powered by something known as Agentic Context Engineering, or ACE for short. It took home the Best Dynamic Evaluation Award, and honestly, it completely rethinks how we build reliable AI.
To really understand why this is such a game changer, we have to look at the daily struggle developers face. Retrieval Augmented Generation, or RAG, is the standard playbook we use to make AI models smart about our private data. You fetch some documents, hand them over to the AI, and ask it for an answer. Simple, right? But as developers try to scale these systems up for actual production, they inevitably hit a massive wall. The AI starts confusing facts, totally losing track of instructions, or just flat out hallucinating entirely new, incorrect connections. It's kind of like that one relative who tells a very confident, very fake story at Thanksgiving.
And here is the hard truth directly from the source material. Production RAG systems rarely fail because of weak retrieval. It's not that they can't find the documents, they fail at synthesis. The AI just gets completely overwhelmed by the raw, messy information and breaks down when it actually tries to stitch it all together into a coherent, factual answer.
Okay, let's dive into this. We're going to cover 5 things today: the problem with standard RAG, the NightFeats architecture, Agentic Context Engineering explained, beating proprietary AI models, and finally, 3 steps for developers.
Starting with Section 1, the problem with standard RAG, the monolithic trap. Let's take a hard look at the antagonist of our story here.
The standard way most people build RAG right now is what the researchers call a monolithic approach. It's this flawed retrieve-then-generate pattern, where retrieved chunks of text are literally just stuffed blindly into a single generation prompt, and you just kind of hope for the best. NightFeats, on the other hand, approaches this entirely differently. It isolates those failure modes by decomposing the whole workflow into strict, very distinct phases.
See, when you collapse everything into one massive prompt like standard RAG does, you basically invite 3 nasty symptoms. First, you get context collapse, where the AI simply forgets or ignores huge chunks of the prompt. Second is brevity bias, where it gives you a super short, incomplete answer just because it's overwhelmed. And third is unverified cross-referencing, where it starts hallucinating crazy connections between completely unrelated documents you fed it.
So, how do we fix this? That brings us to Section 2, the NightFeats architecture, decomposing synthesis. This was developed by Quentin Fever and Nazia Aslam, and again, this is what won Best Dynamic Evaluation at NeurIPS 2025.
NightFeats completely trashes that monolithic pipeline and replaces it with 3 tightly coordinated phases. Step 1 is retrieval, which just gathers the raw candidate documents. Nothing crazy there. Step 2 is curation, which applies temporal semantic re-ranking. Basically, it's heavily filtering results based on how recent and relevant they actually are. And step 3 is composition, which handles bounded contradiction reconciliation. That's a very fancy way of saying it actively resolves conflicting evidence before it ever generates an answer. And they didn't just test this on a toy dataset. They rigorously ran this pipeline against the ClueWeb 22B corpus, which is a massive dataset of over 87 million documents. Now, what's really interesting about this approach is the concept of citation-preserving composition. By separating out these phases, NightFeats ensures that absolutely every single claim the AI generates maps directly back to a verified source document. It keeps the model's context window strictly focused on verified signals, making it practically impossible for the model to just hallucinate connections between unrelated text chunks.
Moving right along to Section 3. Agentic Context Engineering Living Playbooks. Let's look at the underlying principles powering this whole architecture.
ACE positions context engineering as a true, first-class alternative to just constantly fine-tuning model weights. Instead of trying to cram complex instructions into short, static prompts, context is treated as a living playbook. It accumulates and organizes domain-specific tactics over time. By using small, incremental updates, which they call delta items, it preserves useful history and entirely avoids the context collapse that plagues those old monolithic rewrites.
And this living playbook is maintained by 3 distinct roles. The generator executes tasks and exposes what works and what definitely doesn't. Then, the reflector looks at those traces and distills concrete lessons.
Finally, the curator takes those lessons, converts them into those delta items, and merges them deterministically. No AI guesswork involved in the merge. And to prove that this specific structure is the magic ingredient, the researchers isolated the context effects by using the exact same non-thinking DeepSeek v3.1 base LLM across all three of these roles.
Which brings us to Section 4, Beating Proprietary AI Models. It's time to look at the epic battle at the NeurIPS competition and see how this transparent, open-source approach actually fared against the black box giants.
The benchmark gains here are just incredibly impressive. ACE showed a 10.6% average gain on AppWorld agent tasks and an 8.6% gain on complex finance reasoning over the baselines. In fact, on the AppWorld leaderboard, this React plus ACE setup achieved 59.4% accuracy. That almost exactly matches the IBM QGIS score of 60.3%, but it did it using a much smaller open-source-based model, rather than relying on massive proprietary models like GPT 4.1.
But wait, it's not just about accuracy. We also have to talk about speed and efficiency. The ACE framework achieved an average latency reduction of 86.9% compared to strong context adaptation baselines. By avoiding monolithic rewrites and using non-LLM merges for their context updates, meaning they just use fast, standard code instead of expensive AI compute to update the playbook, they slash the adaptation overhead entirely.
And when put head-to-head in the text-to-text track, the NightFeats architecture successfully surpassed proprietary models like Claude, Sonnet V2, and Nova Pro. And it didn't just edge them out on automatic benchmarks. It beat them on both LLM as a judge scoring and rigorous human Likert evaluations.
And this brilliantly illustrates the paper's core conclusion. Humans prefer actual truth over smooth-sounding guesses. Systems that prioritize verifiable evidence, grounding, and explicit contradiction handling are just so much better aligned with human preferences than pipelines too narrowly to maximize automatic similarity metrics like BM25, which, let's be honest, is essentially just basic keyword matching. Structured context simply beats black box optimization.
Let's wrap things up with Section 5, 3 steps for developers. We've seen the academic wins, we've seen the competition results, but how do we actually apply this to our own builds?
If you're building AI systems right now and you desperately want to fix your failing RAG pipelines, the research points to 3 concrete steps. First, enforce schema-based handoffs. Stop relying on free-form prompt injection and start using strict JSON or protobuf schemas between your retrieval, curation, and generation stages. Second, implement bounded contradiction reconciliation. And third, stop relying solely on automatic similarity scores. You need to prioritize human-aligned evaluation metrics, like LLM as a judge, to validate real logical consistency.
Let's look a little closer at that second step because it is absolutely vital. So the crucial point is this. Bounded contradiction reconciliation is a lightweight step right before composition. If retrieved documents contain mutually exclusive facts, say one doc claims Q3 revenue was up and another says it was down, the system has to actively flag or resolve them. This completely prevents the model from synthesizing a weird hybrid hallucination or overwriting verified evidence with a low-confidence guess.
As we wrap up this explainer, I want to leave you with a thought that might just change how you plan your future AI development. The researchers note that if this approach catches on, agent stacks might begin to self-tune primarily through an evolving context playbook, rather than us constantly, painstakingly training new model checkpoints. So, looking at your own projects right now, will your future agent stack rely on expensive weight updates or a structured, evolving context? Thank you so much for joining me to explore this fascinating breakthrough. Keep experimenting and keep learning.